layer and also data link layer. Okay. So we are not going to discuss in detail about the network layer, transport layer, and also application layer. So those are all covered in the next semester. So we'll be focusing on a physical layer, more about the signals, and data link layer. Okay. So more information on error detection, how to detect the error, and also correction methods, and also about accessing the channel. So that we call it as CMAC. And also you will be learning later the different types of networks. Okay, so just remember, we'll be focusing only on the protocols of physical layer and also data link layer. The remaining layers, whatever we have discussed in the previous class, okay, you need to go through that. You need to understand those layers and functionality. That's more than enough for this semester. So this physical layer, about the physical layer, they have covered in 2 modules. So one chapter that comes under module 1, and remaining another chapter, it goes to module 2. So we'll just discuss the basics of physical layer here. Physical layer 1, and they've divided into physical layer 2. It is actually one. They're divided into 2 parts where it is covering 2 chapters. Okay. So in this physical layer 1, we'll be concentrating on more on signals. Okay, that is the main functionality of physical layer, how to represent the data in terms of bits. Okay, and also how to convert these bits into signals, and how these signals are converted or encoded, and that is sent through transmission media. Okay, before converting, it has to be converted into signals. Okay, so what are the methods we are going to use to convert these bits into signals? Okay, is it a analog signal, okay, or is it a digital signal? Okay, what type of signal you are going to convert? So the data is going to convert either of these signals, and that is transmitted. So we'll be focusing on how to represent the data into signals, and also we'll be learning more about some information about the transmission media. Okay, we are not focusing on different types of transmission media, but what are the problem faces with respect to transmission media? Okay, so do you expect, or do you think that whatever the data that is sent, okay, consider the signal is like this, when it is sending from the source, do you think is it received as it is at the destination? No. Okay, so there will be some noise added, or some disturb the signal, the frequency is changed. Okay, something is happened when it is traveling through the transmission media. Okay, the shape of the signal, it is going to change. Okay, so we'll discuss all these methods in detail. So here in the beginning, in today's class, we'll be focusing on what is data and signals. So how to represent data as a signal, different types, then digital signals. Okay, and this chapter covers transmission impairments. That means, so how I was explaining about this. So it is not the signal that is received, it is not same as the signal that is sent by the sender. So there is some imperfection in the received signal. So that is called as, it is something like distraction. Okay, so it is not the actual shape of the signal. So it is changed due to some of the reasons. So we'll be discussing in detail about those reasons. Okay, why impairment is happened. It is nothing but it is harming the signal or distracting the signal. Then data rate limits. Okay, so we are going to discuss some of the parameters to measure the performance of physical layer. Okay, what are the parameters, common parameters are used, we'll be discussing in detail. Okay, so this chapter is more about the signals. Okay, in chapter, this is chapter 3, where we'll be focusing more on a digital data. Okay, so but in the beginning I'll be explaining about both digital and analog data. So now whatever the data that is, I was explaining the data, it is in the form of bits. Okay, ultimately it should be converted. This is the data. Okay, at the physical layer, I have the data in the form of bits, that is ones and zeros. So now this data can be converted into analog or a digital or it can be represented as a analog data or a digital data. So here actually what is the meaning of analog data, how to represent? So analog data refers to information that is continuous. Okay. So when you are representing the data, analog data, it is in the form of continuous. I will give the example for this. Example, if you take analog clock, okay. So if you take analog clock where it is having hours, there is a hand, minute and second. Okay, so here whatever the information you are getting from this analog clock, it is continuous form. Okay, there is a continuous form. There is no sudden changes in the time. Okay, continuously there is a movement. The value is changing continuously. So the movement of hand is continuous. Okay, so one is not becomes directly two. And there it is the data is or the hand is moving through continuous steps to reach two. Okay, so that's why your analog data indicates it's a continuous information. And you can just give this example, that is analog clock. You can just compare. So that is a good example of analog clock. Next, we'll move on to digital data. So the digital data refers to information that has discrete states. Okay, so whatever the information you are going to represent in a digital data, it is a discrete state. That means there is sudden change in the state. Okay, so example, the values. Okay, 0, 1, if it is this value, there is sudden change from 1 to 0. 0 1 to 0, 1 to 0, something like this. Okay, for this example, we can take digital clock. Okay, digital clock that reports the hour and minute and will change suddenly from, okay, so 8:05, okay, 8:05 to 8:06, okay, either AM or PM. So the clock is going to change from this state to this state suddenly. Okay, you will not be having any continuous data to reach here. Discrete, okay, either 1 or 0. So here the number is 5 is changed to 6. So like that there is sudden change in the data. So that is represented as a discrete state. So this representation of information in discrete state, we call it as a digital data. You can take any other examples for analog and digital data. Okay, that is just simple examples where you can compare. Okay, so another example for analog data, that is sounds made by human voice. Okay, whatever the sounds we are making, so that is also an analog data. Take continuous values. Okay, it takes continuous values. When someone speaks, an analog wave is created in the air. So this can be captured by microphone and converted to analog signal, or sampled and converted into digital signal. Okay, so whatever I am speaking, it is represented as a analog data. Okay, it is in the continuous value. So now this information, it is captured in the microphone and that can be converted into a digital signal. So we have different methods how to convert the analog into digital signal. All that different methods will be discussing later. Okay, so here digital data take on discrete values. Okay, so always the digital data, when I use the term digital data, it will be having a discrete values. For example, for digital data, another example is data stored in a computer memory. Okay, the data that is stored in a computer memory is a digital data because it is in the form of zeros and ones. Okay, either it is 0 or it will be 1. Okay, so there is sudden change. So 0 is changed to 1 or 1 is changed to 0. So this type of representation, we call it as digital data, and they can be converted into digital signal. Okay, this data, see, representing 0 and 1, it is a digital data. So ultimately when you want to transfer the data to the other system or to the receiver, it requires to change to digital signal. Okay, so the data should be able to convert into digital signal, modulated into analog signal for transmission across the media. So digital data, either you can convert it into a digital signal, or it can be converted into analog signal also. Okay, so those methods, how it is going to convert this data into signals, either analog signal or digital signal, we'll be discussing in detail in the next chapter, conversion of the signals. So here we'll be focusing only on working with the signals. So what is now we'll move on to analog signal and digital signal. So this is about the data. Okay, there is a difference. So data means that is represented at the physical layer. Example, digital data, ones and zeros. Okay, so ultimately it has to be converted into digital signals. So now how analog and digital signals are represented. So analog signal has infinitely many levels of intensity over a period of time. Okay, so it will be having infinitely many levels of intensity over a period of time. That means you can just see. So this is an example of analog signal. It is having so many infinite number of values to change from this phase to this phase. Okay, it is not changed suddenly. It is having some continuous values. The analog signals will be having the continuous values. Okay, as a wave moves from A to B, it passes through and includes infinite number of values along its path. Okay, so if you are considering this is A and this is B, okay, when the signal, the wave, it is in the form of sine wave. Okay, it moves from point A to point B. Okay, it is passing through the infinite number of levels or infinite number of values, and it reaches to point B. Okay, that is called as analog signal, and it is represented like this. Okay, so here where x-axis indicates the time and y-axis indicates the value, and this is most of the time this is a normal representation of analog signal. Okay, so always remember x-axis indicates the time and y-axis indicates the value, and this is a normal simple sine wave is representation of the analog signal. Okay, next, digital signal. So digital signal can have only limited number of defined values. Okay, so in case of digital signal, it is having limited number of defined values. Through each value can be any number. It is often as simple as ones and zeros. Okay, what are the possible values in case of digital signal? Okay, if I consider this is 1 and this is 0. Okay, 1, 0. Okay, this is also, we have different representation. So here each level indicates it's not necessarily it is 1. Okay, it's not necessarily 0. So there are different types of encoding. So we'll discuss those things later. So either in case of digital signal, the value represented is ones or a zeros. Okay, not or it may be just a combination of these things. Okay, so this is the simplest way to show the signal by plotting them on pair of perpendicular axes. Okay, the same thing I explained. So just remember, you can just observe. You will come to know the clear picture of how analog signal look like, where it is having continuous values. Okay, and digital signal where it can represent fewer number of values in the form of zeros and ones. Okay. So this is about the analog data and analog signal. So data at the physical layer, when it requires to transfer to the destination or the receiver, it has to be converted into signal. Okay. Once again, it can be converted into analog signal or digital signal. But in this syllabus, we are going to focus more on digital signals. Okay, we'll be discussing more information on digital signals rather than analog signals. But you should, some of the terms you should be aware of with respect to analog signals. So those important terms I will be explaining. Even though it is not part of syllabus, you should be knowing that. So next we'll move on to periodic and non-periodic signals. Okay, so what is periodic and non-periodic signal? Both analog and digital signals can take one of two forms, either periodic or non-periodic. So here what is the meaning of periodic signal? So periodic signal completes a pattern within a measurable time frame. Okay, it is having some pattern. Periodic signal, it is having some pattern and that is measurable within a time frame. It is going to complete that pattern within a time. So that is called as periodic signal. So here, and that pattern may repeat over a subsequent identical periods. Okay. So example, if I tell analog, okay, one cycle means there is one positive and one negative cycle. Okay, so this is one pattern. So like this, it can have the same pattern may be repeated over a period of time. Same pattern may be repeated over a period of time. So that is called as a period or a periodic signal. And this is called as a cycle. Okay, one negative, one positive cycle. It is called as, or the full pattern, whatever the pattern I have considered from year to year, that is called as cycle. And this cycle can be repeated for the remaining period of time. Okay, so this is called as periodic signal. So next we have non-periodic signal. So indicates changes without exhibiting a pattern or a cycle that repeats over a time. Okay, so here it is not having any particular pattern in case of non-periodic. It is not having any particular pattern or cycle, and that is going to repeat over a time. So example, you just compare with the analog. Okay, so it is having pattern. Always this cycle may be repeating for the remaining period of time. But digital is one of the example of non-periodic. It is not having any pattern. Okay, it is not having any pattern. So either it can be like this or it can be just the value will be like this. So it is not having any particular pattern. Okay. So this is called as periodic and non-periodic signals. Periodic means there will be a particular pattern. Okay, example cycle that repeats over a period of time. Okay, that may be that pattern is going to repeat for the remaining time. But in case of non-periodic, it is not having any particular pattern. Just some of the terms you need to be aware of it. Okay, the data signals, then how to represent analog and digital signals, then periodic and non-periodic. Okay, so it is once again a particular topic where we need to discuss more detail. So in the textbook they have covered periodic with respect to analog data. Okay, analog signals, but it is not part of syllabus. Periodic signals are not part of syllabus. So we are going to discuss in detail about the non-periodic signals. Okay, so where digital data can be considered for, or digital signal can be considered to represent the non-periodic signal. Okay, so now we'll move on to this in detail to understand how non-periodic signals can be represented. Okay, so with the example of digital signal, I am not going to explain in detail about the analog signal. So if possible, you people just go through some of the terms, what it is covered. Okay, what is wavelength, what is frequency, okay, how analog signals are. See this here they've explained more on analog signals. I want you people to just spend time on analog signals. So I will start directly with the digital signal. So where and all it requires some of the terms from the analog signal I will be covering. Next, so we'll start with the digital signals. Okay, so digital data can be represented as a digital signal. So digital data, whatever it is there at the physical layer, okay, so that is represented as signal. Okay, example 0 1 0 1 something like this. Okay, now it has to be converted into signal. So let me represent. There are different ways. I'll be just showing one method. So 1 0 1 0 1. Okay, so this is my digital data. This is data and this is my signal. When it goes through the transmission media, it has to be converted like this in the form of signal. Okay, and this is sent to the receiver. Once again, this signal is converted back into the data 10101. Okay, if it is not same, then the other layers, data link layer, will take care of identifying the mistake or the error and it will correct. Okay, don't worry about that. We'll be just going through this part. Okay, so when the data is there, how converted into signal, okay, and what are the methods we are going to use, all that we are going to discuss in detail. For example, okay, so here the same thing, whatever I have specified here. So for 0 will be representing positive voltage. Okay, and if I want to represent digital data as 0, it is I am representing 0 voltage, same thing. Okay, 1 means positive, 0 the data 0 I am representing with 0 voltage. Okay, positive 0 positive. Okay, this is one type of representing the digital signal. So we have many types. We'll discuss those methods in the next chapter. So digital signal can have more than two levels. It can have more than two levels. In this case, we can send more than one bit for each level. Okay, so here we are sending only one bit. So we have different ways. So in that case, we can send more than one bit. So I can represent, so 1 0 here, okay, then 0 1 here, something like that. More than one bit I can represent each level. So in this case, when I am representing more than one bit, it requires more number of levels. If it is only 1 and 0, it requires only two levels. Okay, positive level and negative 0 voltage level. If I am representing more than one bit, then it requires more number of levels to represent the data. So are you people are understanding? If any doubt, you can just interrupt me so that I can answer to your question. Okay. Okay. So now we'll take example how we can represent more than one bit and how it requires more than two levels to represent the data. Okay. So here we have two figures. So the first case, one with two levels, each with 4. Okay. Let me go to the diagram. So here I am representing, just focus on to this diagram. So this is digital data with two levels. Okay. So level 1 and level 2. This is 0 voltage level and this is positive voltage level. Okay. And depending on the data, whatever it is there, you just take time axis, that is x axis is represented as time, and y axis you need to represent it as a amplitude. Okay, so level 2 I am representing 1 and level 1 I am representing 0 voltage. Okay, so that means I am representing bit 0. Okay, then you can just observe, if I have bit 1 1, so the voltage is continued for these two cycles, then 0 0 1. Okay, so here you can just observe how many bits are sent. It sent 8 bits. Okay, so number of bits sent per second, so we call it as a bit rate. How many number of bits we are sending, so that is called as how many bits the physical layer or the transmission media is able to send per second. Okay, that is important, per second. Per second, so that is called as bit rate, and it is represented in terms of BPS, stands for bits per second. how many bits sent per second. Okay, according to this diagram A, so 8 bits sent per second. If I consider this duration from year to year, if it is 1 second, okay, so number of bits sent is 8 bits. So we have another diagram here where I have 4 levels. Okay, the data is represented with 4 levels. That means each level is representing 2 bits. Okay, level 4, 3, 2, 1. Okay, so this level 4 always represent value 1 1, then 3 it is 1 0, then level 2 is representing 0 1. You can just observe wherever 0 1 comes, it comes like this. Then if it is 0, it is represented with level 1. Okay, if it is 1 0. So this is how we can represent the data using more number of levels, more than 2 levels. It's possible. Okay, digital signals with 4 levels, where each level is going to indicate 2 bits information. So now if this is a case, so in 1 second how many bits are sent? Okay, you can just observe. So it is 16 bits. You can just count it. So total number of bits sent is 60 bits, 16 bits. So that means bit rate here it is 16 bps. It is going to send 16 bits per second if I go with 4 levels of representing the digital signal. If you keep on increase the levels, obviously the bit rate is going to be more. Okay, is it clear? Okay, so now we'll just discuss uh, one or two problems with respect to bit rate. So any doubt in this digital signal and this diagram representation of digital signal with the 2 levels and also 4 levels? So I will take one example here. This is once again with respect to bit rate. So here what is bit rate? I told already, that is number of bits sent in 1 second is nothing but bit rate, and it is expressed in terms of bps, bits per second. So now we'll go with the problem. Just it is an assumption. So assume we need to download. Okay, so if you want to download a text document at the rate of 100 pages per second. Okay, you want to download a text document contains 100 pages per second. So in that case, what is the bit rate of the channel you need to calculate? Okay, they have not given bit rate and to find how many pages to be you can download. Okay, they have given you need to download 100 pages and you need to calculate what is the bit rate of the channel it requires to download 100 pages per second. Okay, so it is just a not standard value. Okay, we are assuming some of the value. So here a page is an average of 24 lines. Okay, so always when I tell page, it will be having 24 lines. Then character, number of characters in each line. Okay, in each line it is 80 characters. Line means here. Okay, whatever you are going to type horizontally in a single line. So here I have assumed it is 80 characters. 80 characters. Okay, in each line, and we assume that one bit requires 8 bits. Okay, you already know. So whatever the information representing in a line or in that particular page, so each character, okay, it is represented with 8 bits. Okay, so just calculate. We have 100 pages. Okay, multiply. So these 100 pages, each page it is having 24 lines. Okay, and that particular page it is having 80 characters per line. Okay, and each characters requires 8 bits. Okay, you just calculate this. Okay, multiply all this, you are going to get this value. Okay, 15 lakh 36,000 bits per second. Okay, so this is a channel bit rate. Whatever the transmission media I told here between the two nodes, whatever it is, their physical layer. Okay, I mean physical transmission media. So that should be the channel or the transmission media. It should have this capacity of the bit rate where it can send. Okay, number of bits sent per second is this much. If you want to download 100 pages per second, okay, and this should be the bit rate. Is it clear? Is it clear? This is the channel bit rate if you want to download 100 pages per second. Any doubt in the first problem? See here, you need to understand the problems. First you need to understand what is the question given. Okay, if you understand the question, then you can easily solve the problem by specifying the proper unit. Okay, so if you don't have any doubt, let me move to the next one. So another example. So a digitized voice channel is made by digitizing 4 kilohertz bandwidth analog voice signal. Okay, so here the bandwidth of 4 kilohertz. We need to sample signal twice the highest frequency. Okay, twice the highest frequency. So we assume that sample requires 8 bits. So what is the required bit rate? Okay, so here once again you need to calculate what is the required bit rate. Okay, so here the frequency it is twice the frequency. So take 2, and what is the bandwidth they have specified here? So 4 kilohertz, that is 4 into 10 power 3 multiplied by, so each sample requires 8 bits. Okay, so if you multiply this, you will be getting 64 kilobits per second. Okay, so in case if you are not able to understand the second one, so don't worry. So because for that you should know what is frequency and all. Okay, so I'll be covering those terms, and then you can go back to this problem and you can just try to understand. Okay, so this is about bit rate. So now before going to the in detail about this periodic signals, I will just cover some part of the analog periodic signal. Okay, analog periodic signal. So how to represent the sine wave? So this is how the analog signal look like. It is just like a simple sine wave. Okay, this is an example of analog signal. It is nothing but simple sine wave. So here you can just observe amplitude of the signal. How you are going to measure? You can just observe this is the amplitude of the signal. Peak amplitude indicates the highest intensity, so that value is going to be indicated as the amplitude. Okay, so here you can just observe signal with high peak amplitude, and this is a signal with low peak amplitude. So that means intensity is reduced here. Here it is more. So here you need to understand some of the terms. One is period. So what is this period refers? The amount of time. Okay, so it indicates amount of time in seconds the signal leads to complete one cycle. Okay, that means how much time it requires. How much time it requires to cover one cycle. Okay, this is one cycle. See, I told these are the terms with respect to analog data. It is actually not part of syllabus, but we'll be using these terms. So I'm just adding the important terms here. So period means, so how much time it requires to cover this one cycle. Okay, so that is called as period. So now what is frequency? A frequency refers to number of periods in 1 second. Okay, in 1 second, how many periods occurred? Okay, how many number of cycles occurred? So that is called as a frequency. Okay, so your frequency you can just indicate it as 1 by t. Okay, or if you want to calculate a period from the frequency, it is just inverse of each other. T is equal to 1 by f. Is it clear now? Period means how much time it requires to complete one cycle. So that is called period. So frequency means how many number of periods covered in 1 second. Okay, so that is called as frequency. So it will be represented like this: in 1 second how many frequency it is covered. So you should be able to calculate. This is 1 second how many frequency it is covered. So the total count it is going to be called as frequency. Okay. You can just observe the frequency is not same. So I have two diagrams. This is one diagram and this is second diagram. Just observe. I am telling it is having two different frequencies. How many frequency the first diagram is having? I am considering this whole duration. See, observe here. So neatly they have given in the diagram. So this duration where it is covering one cycle. Okay, where it is covering one cycle, it is called as period. So like this period, okay, like this cycle, how many cycles it is going to cover in 1 second? So this is my 1 second duration from year to year. So like this pattern, how many it is occurred? So that is called as frequency. Okay, you just observe how many frequency occurred here. So this is 1, okay, this is 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. Okay, so 12 hertz. Normally frequency is represented with the unit hertz. Okay, so 12 period in 1 second. Nothing but frequency here it is 12 hertz. Okay, 12 hertz. Similarly, you just check the below diagram. Okay, here you can just observe the period time is also more here. Okay, so if the period time is less, so the number of cycles per second is it is going to be more. If it is taking more